But Earth's rotation doesn't just affect day and night, it also influences weather patterns and ocean currents through something called the Coriolis effect. Imagine trying to walk in a straight line on a spinning merry-go-round. You'd end up curving instead. Similarly, air and water currents on Earth curve as they travel long distances, all thanks to our planet's spin. Biologist. This continuous rotation even plays a role in our internal clocks, known as circadian rhythms. Our bodies are naturally programmed to a roughly 24-hour cycle, affecting sleep, hormone release, and other bodily functions. This rhythm is closely linked to the cycle of day and night created by Earth's rotation. At the same time that Earth spins on its axis, completing one full rotation every 24 hours, it's also traveling around the Sun in a path called an orbit, moving at an average speed of about 67,000 miles per hour. This orbit is not a perfect circle, but slightly oval-shaped, which we call an ellipse. This elliptical shape means that the distance between Earth and the Sun changes throughout the year. That means Earth gets a bit closer to the Sun at some points and farther away at others during its journey. When Earth is closest to the Sun, it's called perihelion, and when it's farthest, it's called aphelion. It takes Earth approximately 365.25 days to complete one full orbit around the Sun. This extra quarter of a day accumulates, leading to the addition of a leap day every 4 years. This period is what we call a year. Our calendar year is based on this orbital period. Think of it as one lap around a giant racetrack in space. Each lap brings us through the cycle of seasons and marks the passage of time. Astronomer. This orbital motion, along with Earth's tilt, is what gives us our seasons. The tilt of Earth's axis is about 23.5 degrees, which is crucial for the changing seasons. As Earth travels around the Sun, different parts of the planet receive varying amounts of direct sunlight throughout the year. This variation in sunlight is what causes the temperature changes we associate with different seasons. When the northern hemisphere is tilted towards the Sun, it experiences summer, enjoying longer days and more direct sunlight. While the southern hemisphere experiences winter, with shorter days and less direct sunlight, and vice versa. This beautiful dance of Earth around the Sun creates the rhythm of our year. Now let's talk about Earth's tilt. Imagine Earth isn't perfectly upright, but leaning to one side as it orbits the Sun. This tilt is not just a minor detail, it's a fundamental aspect of how our planet functions. This tilt, about 23.5 degrees, is crucial for life as we know it. Without it, our planet would be a very different place, with potentially drastic changes in climate and seasons. Astronomer. Because of this tilt, different parts of Earth receive varying amounts of sunlight throughout the year. This variation in sunlight is what creates the seasons, influencing everything from weather patterns to the growth cycles of plants. During summer in a hemisphere, that part of Earth is tilted toward the Sun, receiving more direct sunlight and experiencing warmer temperatures. This is why summer days feel so long and hot. During winter, the same hemisphere is tilted away, receiving less direct sunlight and resulting in colder temperatures. The shorter days and longer nights make winter feel much colder and darker. This tilt also explains why days are longer in the summer and shorter in the winter. The angle of the tilt affects how much sunlight each hemisphere receives. When a hemisphere is tilted towards the Sun, it spends more time facing the sunlight, resulting in longer days. This extended exposure to sunlight is what makes summer days seem to stretch on forever. The opposite occurs when it's tilted away. The reduced sunlight means shorter days and longer nights, contributing to the cold and often gloomy feel of winter. This cyclical pattern is a beautiful reminder of the Earth's dynamic nature. Earth doesn't journey through space alone. It is part of a vast and intricate cosmic neighborhood. We are part of a fascinating and dynamic system called the solar system, a collection of celestial bodies bound together by gravity. At the heart of this system is the Sun, a giant ball of hot gas that provides light and heat to everything around it. The Sun's immense gravitational pull keeps the entire solar system in motion. Orbiting the Sun are 8 planets, each with its own unique characteristics and features that make them distinct. We have rocky planets like Mercury, Venus, Earth, and Mars. These terrestrial planets have solid, rocky surfaces and are closer to the Sun. Then there are gas giants, Jupiter, Saturn, Uranus, and Neptune. These planets are much larger and composed mostly of gases like hydrogen and helium. These planets vary greatly in size, composition, and even the presence of rings and moons. For instance, Saturn is famous for its stunning ring system. while Jupiter has a multitude of moons. Our solar system is also teeming with smaller objects like asteroids, mostly found in a belt between Mars and Jupiter. These rocky remnants from the early solar system offer clues about its formation. Then there's the Kuiper Belt, a region beyond Neptune filled with icy bodies. This area is home to dwarf planets like Pluto and countless other icy objects. And let's not forget the Oort Cloud, a distant and mysterious realm thought to be home to trillions of comets. This vast spherical shell surrounds our solar system and marks its outermost boundary.